Our last and final lesson in volume is dealing with spheres. And the reason we're doing spheres last is because it's kind of special. A sphere, if you think of a sphere, it doesn't have a base and it doesn't have any faces. So we aren't able to use the volume formula that we've been using, V equals capital B times H. Okay, that doesn't work. So we have to kind of figure out a different way to find volume of a sphere. So let's talk about the definition of sphere first. We all know what one looks like. But mathematically, the definition is a set of all points in space that are a given distance, known as the radius, from a given point, known as the center. So if you take a look at the picture right here, here's the center, and here's a radius. Now normally we just see one radius when we're dealing with circles, but a sphere has an infinite number of radiuses, or radii, and they're coming out in all three dimensions, and it forms this sphere because all of the radii are the same length. Okay, so describe the cross section, the shape of the cross section. This was just like our inquiry lab. Okay, if we slice this in half, what would that cross section look like? It would be a circle. Okay, name this part of the sphere. Okay, this is the radius. Name this part of the sphere. What is in the very middle? What is that point called? Okay, that's the center. And then name two examples of a sphere. You guys can write your own examples, and we did this in the inquiry lab. A ball, an orange, the earth. Okay, those are all examples of spheres. Okay, Brittany purchased a necklace that contained a round pearl with a diameter of 0.75 millimeters. What is the circumference of the largest circle around the outside of the pearl? Round your answer to the nearest tenth. Okay, so we know how to find circumference. That's pi d. So if we take pi times the diameter, okay, which is 7.5, we should get about 23.6. Okay, so maybe that might be important here. Okay, let's look at the exact formula for finding volume of a sphere. Okay, it's right here. Okay, volume equals 4/3 pi r cubed. Now some of this might look familiar to you. Okay, the pi r, normally we're dealing with pi r squared because that's the area of a circle. But what we're going to do is pi r cubed, or to the third power this time. And we're multiplying it by more than just 1/3, which are like our cones in our pyramids. We're now going to multiply it by 4/3, which is one whole and another third. Okay, so this is the formula that we are going to use. Okay, you don't need to start off like this, like how we've been doing it. Okay, you don't need to do this because one, we don't have a base. Okay, so this gone. So this kind of saves you an extra step. Okay, let's look at an example. Find the volume of a sphere and round to the nearest tenth. Alright, so we're going to start with our formula. V equals 4/3 pi r cubed. Okay, then plug in what you know. Well, they give you 4/3 and they give you pi. Look for your radius. Well, here's your radius, 6 millimeters. Plug that in and cube it. Okay, if you mess up in this, it's probably because you're so used to putting a square here, you're going to put a 2. But keep in mind, it is a 3. And your answer is approximately 904.8. Okay, here are two got it problems. Be careful on this one because this gives you the diameter. Okay, and this one will just gives you the radius. Okay, so go ahead, pause the video and try your two got it problems. Letter A. Okay, we're going to start with our formula, 4/3 pi r cubed. All you need to look for, because this is given and this is given, is just your radius. Well, if your diameter is 22, your radius is going to be 11. So 4/3 times pi times 11 cubed should give you 5,572.5, approximately. Okay. Let's look at this one. This one, the only difference between this one and this one is that they give you the radius this time instead of the diameter. So we set it up the exact same way. 4/3 pi r cubed. Your radius is 5. Okay, so your final answer, 523.3 millimeters cubed. Okay, it's as simple as that. Okay, now here's a word problem. A spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone, round to the nearest tenth. Okay, well, here's the information that you need right here. Okay, now for your formula, you need the radius. They give you the diameter. So what's half of 8? 4. Plug in your information, and you get approximately 268.1. Okay. Here's your got it problem C. A dish contains a spherical scoop of vanilla ice cream with a radius of 1.2 inches. What is the volume of the ice cream? Alright, pause it and you guys try it. Okay, let's start with our formula. 4/3 pi r cubed. Plug in the radius of 1.2. Cube it. Then multiply by pi and 4/3. You should get approximately 7.2 inches cubed. Okay? Alright, on to the next example. A volleyball has a diameter of 10 inches. A pump can inflate the ball at a rate of 325 cubic inches per minute. How long will it take to inflate the ball? Round to the nearest tenth. Okay, so what we have to do first, we have to find the volume of the volleyball first. That's our first step. Okay, and they told you that the diameter is 10 inches. Okay, so the radius then would be 5. So they plug it in their formula, 4/3 times pi times 5 cubed. Okay, here's our volume of the volleyball. Okay, but they just don't ask for the volume. They want to know how long will it take to inflate the ball. Well, the other information that they give us, it tells us the rate, and here's the rate. Okay, so what we can do, we can use a proportion. Okay, if we know that it takes 325, it inflates at 325 cubic inches per minute, there's our first fraction right here. Okay, look. Here's our first fraction. 325 cubic inches per minute. Okay. How long does it take to inflate the ball? Well, here's our other ratio. We know that the volume is right here. We want to know, well, how long does it take to inflate a ball this size? Okay. Again, you can see that the volume is on top, the time is on the bottom. So you guys know how to solve proportions. Cross multiply. So 325 times x gives you 325x. 1 times 523.6 is 523.6. You're going to divide both sides by 325. That's a 2. And it's going to take approximately 1.6 minutes to inflate that ball. And again, we just set up a proportion based on what they gave us. Okay? Here's a similar problem. This is your last got it problem here. A snowball has a diameter of 6 centimeters. How long would it take the snowball to melt if it melts at a rate of 1.8 cubic centimeters per minute? Round to the nearest tenth. Okay, so the first thing you have to do is you have to find the volume of that snowball. The second thing you need to do is set up a proportion. If you have trouble, go back and look at the previous example. So I'll pause it and you guys go ahead and try your got it problem. Okay, let's see how you did on the volume. There's our formula. The radius is going to be 3. When we multiply it out, we should get 113.0 if we've rounded correctly. Okay. Now we need to take this and we need to set up a proportion. Okay. Here's the other thing you need. 1.8 cubic centimeters per minute. Okay. So here's our proportion. 1.8 cubic meters per minute. Our other volume is 113, and if you put 0.0 on there, that's fine. Okay, and we want to know how many minutes it's going to take to do this. So minutes are on the bottom, cubic centimeters are on top. Let's cross multiply. Okay. Then we divide both sides by 1.8. It's going to take approximately 62 minutes, 62.8 minutes to get that snowball to melt. Okay? Alright, so what you need to do, go ahead and work on the got it problems and be happy because this is your last volume lesson. We're moving on to surface area next. Okay?